All right, we have a very expensive Samsung laptop that's secretly a Chromebook, but it's $1,200, so we're gonna fix the board. I believe something was spilled on it. I don't know if it was wine or coffee or something like that. It looks really clean, actually. Didn't really see anything immediately that concerned me. But upon further inspection, we see a little bit right here. And you can see this chip is cracked. I actually remember I looked at this with the customer waiting in here, and I had like a brain blast moment. I'm like, I've seen this chip before. There was a Razer gaming laptop I fixed probably a year ago, and I think I just ordered a pack of 5 of these. And I have some here, which is absolutely bizarre, because otherwise I would need to wait like 3 weeks to get these. I even joked that I would never ever use this chip again, and why am I ordering 5? So this is like a good reinforcement of bad behavior, is ordering more stuff than what you need, just in case you might use it later. This is like early onset dad behavior. I thought that was kind of funny. This is probably a simple repair. I think just this chip's bad, basically. We're going to take out the board and look at it further. Maybe there's a big, huge mess on the back side of the board, and this will be a massive headache, but I sure hope it's not. So we'll get the board out and go from there. I will say, generically, I was telling my technicians over here to the right, this young man, as I work on more Windows machines, I do appreciate the MacBook a little bit more. MacBooks, I think, actually fail much more for silly ways, but generally it's a little bit more innocuous, short of like the SSD regulator 16-inch. Ooh, that's a bad one. When Windows machines fail, it's like their prank is like they shoot the computer in the head and kill the CPU. These sort of high-side MOSFET shorts will kill the brain of the computer half the time, at least. I feel like the bulk of Windows board repairs that we actually get in, they're no fixes because the processor is dead, either a GPU die or a CPU die. And really the idea of rehotting the chip, or rather, replacing the chip, like they're not meant to go through that many thermal cycles. You have something that's just going to fail inside of a year almost always. So in that case, you just need to swap out the whole board, which sucks. This is like a liquid damage case in a really specific area. We did look at the backside of the board, and I guess even the top side one's not really obvious unless you're under the microscope. It's really clean. I don't see anything that worries me, nor inside the chassis. I will say also, I was really ready to shit on this computer, but it actually has a pretty nice build quality, I will say. It's kind of like a better put together LG Gram. This is basically the same layout in the chassis you see on like the Samsung 15-inch Chromebooks. We get those in from school districts quite a bit, so I'm unfortunately very familiar with them. But this is like a nice metal milled aluminum frame, and the keyboard's actually it's screwed in, not riveted, which is nice. We'll see. If the board doesn't work after I replace this MOSFET, then the computer's a piece of shit, so we'll see. I did want to show what it's doing, because I didn't initially just like see that. I saw it was, I think, just doing 5 volts, like a couple watts. We can look at our thermal camera vision. But we plug in USB-C, and it's drawing like 0.5 amp immediately, and we can see this chip's getting really, really hot. Basically, that's pretty much the behavior we see. We don't need to let this run anymore. That sort of behavior, right? So similar in that video I had on the Razer gaming laptop, this kind of failed in a different way, where I think an earlier stage rail was short-circuiting like the main 20 volt, because that one you wouldn't see any thermal signaling unless you injected voltage into the line. So that we see this getting hot when we're sending power directly on USB-C means some later stage rail is shorting, which kind of gives me more hope that the CPU is not just dead, basically. I'm going to get this heatsink off, and then we'll just switch over to microscope view and get this chip off, replace it. Okay, so we don't have any schematics for this. We do have a little bit of swag. So we're going to use swag to find some replacement caps for these guys. Really, my thinking here is I have a bunch of dead, Windows laptops in the back. I just grabbed something that's definitely rated for enough power, So I think we're just gonna grab a few fellas off of this like ROG Zephyrus machine, specifically these sort of blokes right here, like this guy and this guy right there, and then it's probably fine. We're gonna clean off the area, get the chip off, get those caps swapped out, see what happens. Getting on some new gloves. Do you have like a large reel of Kapton tape, like a wider one? Mine seems to have disappeared. Thanks. Don't feel like reballing this CPU, so do that. I would say, yeah, those caps don't look happy at all to me, so let's get them off. I'm gonna turn on the fume extractor. Get some flux on here. And let's get this crap off this precious Samsung board. Our pin 1 is in the upper left. We will remember that for later. Upon further inspection, I think I'm just going to remove this guy. He looks less happy to me. Eyes are deceiving me today. This kept looking like it was on and I could let go. These little excess things, but on this one, since it's all flat pads, we can just kind of push it down into place and just leave the existing lead-free solder. It's fine. Oh yeah, I want to get a little cap on here. No, it's fine. And let's get a little fella here. Actually, probably one of these would be more appropriate now. He's kind of doing the same sort of thing. Someone knows more about that than me. I think these caps are just for like filtering kind of transients for power delivery to the CPU. There's some technical jargon for you. Okay. All right. Well, let's cool down and we'll see if it works now. If we needed to replace this cap. Probably not. It was just kind of dirty. Whatever. Okay. Cleaning while the board is warm here. Don't worry, we're gonna get in there with a magic eraser in a second. I would say it's always, well, I prefer to just get it with a Q-tip and alcohol to kind of get the bulk of the flux off. And then we use the little magic eraser acetone method. Ooh, look at that. We have a green light and 20 volts now. Still really low. I think this probably needs to have the power button pressed for it to turn on, like a lot of Windows machines. It actually won't go into later stage power rails until you do that. We will put this back together and test it further. I think this will work now. We'll see. To quote the great Howie Mandel, this is how we do it. Seems fine. We're gonna run some stress testing on it just to make sure, but fairly straightforward. Nice. Well, we take those, so I like not dealing with a big mess that takes me many hours to figure out. So pretty lucky, all things considered. Most of the time when you see this sort of issue, it's not from liquid damage. You get a high side MOSFET short and it kills the brain on the computer, which sucks. In this case, we had some corrosion near that part that caused a different kind of issue on a similar component, and I happen to have the chip here, which is nice. Normally I'd have to wait like a month to get it. I just have a Nintendo Switch on my board. We're going to do a Bluetooth IC on that later. Well, hopefully this helps someone or you found it entertaining, and we'll see you next time, buddies.